Hi, good evening. I'm going to talk about advanced encryption standard in the blockchain we are using to. Let's see what are the advantages, what are the features of that, how is the going to work in the architecture of that, and how it's going to work in the encryption and decryption for that key generating and overall things. Let's see. We call them as shortly as AES, which is Advanced Encryption Standard, and also known as regional, is the most popular and widely used symmetric encryption algorithm in the modern IoT industries. And this is because that AES is a proven to be highly secure and fast and well standardized and very well supported on virtually all platforms. AE was developed by National Institute of Standard and Technology in the US in 1997. It was developed for replacing DES, which was slow and was vulnerable to various attacks. So therefore, a new encryption algorithm was made to overcome the shortcomings of DES. AES was advanced encryption standard was published on 26 November 2011. AES stand for that and is majorly used symmetric encryption algorithm. It is mainly used for the encryption and protection of electronic data. It was used as a replacement of the ES and it's much faster and better than ES. AES consists of a 3-block cipher, and this cipher are used to provide encryptions of the data. And the 3 cipher blocks are 128 blocks, and usually 128 blocks is used for that, and the 3 is 128 blocks 190 and 256 secret key with use for that one, and there will be that, and it is usually used in block mode like ACCTR as to process streaming data in most blocks mode, and AES requires almost a random 128-bit initial. As I said, there will be 3 blocks, 128 and 28, 156 and more there. It is based on substitution permutation network and also known as SP for that SP network, and it consists of a series of link operations, link including replacing inputs with a specific outputs and other involving bit shuffling permutation. Or these are the characteristic of AES. There are 3 length for that one. As I said, it is a flexible and has implementation for software and hardware. It provides high security and can prevent many attacks. It doesn't have any copyright, so it can easily use globally. It consists of 10 rounds of processing for 128-bit keys. And the features of advanced encryption standard is SP network. It works on a SP network structure rather than a crystal cipher structure as seen in the case of a AES algorithm. And the key expansion, it takes a single key up during the first state, which is later expanded to multiple keys using an individual round, as I will show you in the architecture of what's going on in the key expansion. And byte data, the ES encryption algorithm does operation on the byte data instead of big bit byte data, byte and bit data. So it treated that 128-bit block size as 16 bytes during the encryption procedure. And the key length was that the number of rounds to be carried out depends on the length of the keys being used to encrypt data. The 128-bit size has 10 rounds, and the 192-bit key size has 12 rounds, and the 256-bit key size has 14 rounds for that one. Let's get on the symmetric key algorithm, which is used in the advanced encryption standard for that. And here comes that the key where in the from the plain text to the ciphertext for the encryption and decryption, the key is the same one, and the key is used in that one. Both is the same key which uses one, and might be somewhat secure issue, but is what the main thing for that one. Let's get to the characteristic of the secret that both the symmetric key and the secret key cryptography. It's also known as, we call them as secret key cryptography for that one. Is the key which is used in the encryption and the decryption for that one. Both the parties have the same key to keeping secret. It is suited for bulk encryption. It requires a less computation power and faster transport. let's get to the working of that architecture of how it's working going on. Let's see. It has 4 rounds in that, from the plain text to the ciphertext, and each will generate the k plus n plus 1 keys over there, and the round, for each round there will be generated keys, and overall n plus 1 rounds will be gathered towards overall that. And if you see that sub and shift rows, max columns and rows, these are the just for the one key generating, and overall it will rotate for the n plus 1 keys. And this was, and I will go use to explain with the explain example over that and the basic steps over that. Suppose it was a string and it was converted in the plain text. Let's get in the seed on how encryption works for overall that one. And go overall through this was the overall, so you can see that in our one. Okay, and first the basic one like plain text is generated, and then the keys will generated, as you can see, as like the plain text and encryption converts the key to hexa format before the operation began. Accordingly, you can generate the key for the next 10 rounds, as you can see in this round, like they will be 10 round n plus 1, so 11 all around, the 11 key will be generated for that one. So this was the second round for that one, and they are the round to sequentially extracting the state array and passing it off as input to the next round. The steps are follows as you see, and this is the steps we need to follow. The add round keys with this new state and the plain text and the round okay will have an XOR operation from that the key generator is going to happen for that. You pass the block data stored in the state array. If you can place, as I said, from the get, we get from the it's the from that this was a key generated. That key is going to have in the 16 block size of matrix. From that, a plain text is generated from that, and you pass the block stored in the state array through an XOR function with the first key generated. You can see that 54 is the first key on the overall letter, and it passed through the resultant state array as an input to the next step for that one. And from that, the new state array is the input for the next round for that one. And the sub byte here it comes up. It converts each byte of state array into an hexadecimal into 2 equal parts. These parts are the rows and a column mapped with a substitution box with columns 10 rows key, and to generate a values for the final state array. From that, we have generated for that. You can see in the state array, they will be like around values. From that, we have generated the hexadecimal values for that one. And now come here the shift array. It swapped the rows element among each other. It skipped the first row because there is no one, and the 0, 1, 2, 3, and the number of rows from that one they're going to skip for the swapping for will happen. In the first row, there is no skip row, and if the shift elements in the second row and one position to the left one, and if you can see C0, it's shifted towards the last, and then it comes for that one, and it's also shifted the element from the third row to the second position of that one, and the shifted to the fourth one, and it's come towards, as you can see. And then we can move to the mixed column. In the mixed column, it multiplies a constant matrix with each column in the state array to get a new columns for the subsequent state array. Its multiplication is once all the columns are multiplied with the same consistent matrix, you get your state array for the next step. And this particular step is not to be done in the last round. In the ciphertext, there will be no mixed column. And here we come add round keys. And the old state, the respective key for the round is XOR D, which we call as a round 1 key, and the old state 1, and then the state array is obtained in the previous step. If this is the last round, the resultant state array becomes the ciphertext for the specific block. Else pass the new state array input for the next round. If it's like if the number of n plus 1 rounds is get over, and then the plain text will get open. And the final one is come here that the final matrix over that, and each will be generated and a final output from that, and the ciphertext will be converted for that. Let's see the applications of overall what we can see that it's used in wireless security. Wireless networks are secure using the advanced encryption standard to authenticate router and clients. Wi-Fi networks have a firmware, software, and a complete security system based on this algorithm and rules in everyday we use. And second, we goes an encrypted browsing. It plays a huge role in securing website server authentication from the both client and server, and with the both symmetric and asymmetric encryption being used in that encryption. But this algorithm helps in SL and TLC encryption protocols to always browse with the utmost security and privacy. General file encryption for the apart from the corporate necessity, AES also used to transfer file between associated in an encrypted format. The encrypted form information can extend it to chat messages, family pictures, and legal for that document for that one. And these are the advantages for that one. It can be implemented in both hardware and software. You can see, and it provides high security to user. It provides one of the best open source solution for the encryption, and it's very robust algorithm for that one. And a disadvantage for it's like require many round for encryption. It is hard to implement on software. It needs much processing at different state. It is difficult to implement when processing has to be considered. Thank you very much for that. अरे